So in this lecture we will cover this part of the first module, that is math module. You can see here using the math module. So in the last video we covered the basic input output operations, print and input. Okay, so now we will start math module. So math module consists of some mathematical functions. So the syntax is given here. The first line is import math. That is common to all. Whenever we have to use or call any functions included in the math module, we have to import math. So that's the first line. And second line is for calling that particular function, in addition to the function name, we have to give math dot to show that it is in the math module. So this is the extension, math dot function name. So function can be a very simple example is square root. We have a function called sqrt in math module. So instead of calling sqrt function, you have to call math.sqrt function. So inside the parenthesis you can give 49. So here the result will be 7. We know that square root of 49 is 7. So in that case, to get this value printed, you can put a print before that. So that is shown in this syntax. So first two lines is, first line is to import the math module and second is to call the function. And if you need to print the value, you can add print before math.function name. So this is the function. For function call we use this parenthesis. This is how we generally call a function, and this is math, that's the name of the module. So this is the simple syntax for using a function defined in math module. And now we can check the different functions which are included in math module. So all these are very simple one line code. So in the first line we have already imported math, and after importing math you can use whatever functions that are included in math. So first function is sqrt for finding the square root. So sqrt of 49, the answer will be 7. Then math dot factorial of 6. This will give the factorial of 6. We know that 6 factorial equals 6 into 5 into 4 into 3 into 2 into 1. So that value is 720. It is shown here. Then FABS, it gives the absolute value of minus 8.34. So that negative sign is removed and the absolute value is 8.34. Then power. Power function is POWA comma B. This will math dot. Math dot is mandatory as this is a function defined in math module, and this will give the value of A raised to B. So in this case 4 raised to 3 is equal to 4 into 4 into 4, which is 64. So you get the value. So these are the functions. There are many functions. I am just adding some functions. So sqrt for finding square root, factorial to find the factorial, FABS for getting the absolute value, and POW, it gives the power. Okay, so these are different functions included in math module. Next, again the different functions. So we have covered all this, and this exponential expx, this will give the value of e raised to x. So if I need e square, exp math.exp of 2, math.exp of 2 will give this value. To print, you have to put a print before. So you can see here e raised to 1, e value is shown here. Then to get log value, log 32 comma 2 means this gives log 32 to the base 2, which is 5. You get the output as 5. So here there is a correction, it is 5. Okay, 2 of 32. Okay, so 32 to the base 2 is 5. Then this is log 100 to the base 10. So the answer will be 2, which is again shown here. So these are the functions sqrt, POW, exponential exp, and log x comma base. Again there are different functions. All these are included in math module itself. Then we can find the values of constants here. Math.pi, math.e, all these are the mathematical constants, the real values saved in math module. So we can get it. For example, if we need to find the area of a circle for pi r square. Okay, so pi star r, this is area, right? A equals, so instead of pi we should write math dot pi. You have to write like this, and before that you have to import math. So after importing math, if you give math.pi, the pi value will be directly obtained from the math module. Then multiplying that value with r star r, you will get the area of a circle with radius r. So like that we can use the constant values. Then sine, cos, tan, different functions are there. Then to get inverse, we have a sine, a cos and a tan functions. And note that in all these cases, x should be in radians. Okay, so if we have degree, to convert to radian, we have radians x, and to convert radian to degree, you have degrees x. So just remember the names of all these functions. So you can see that all these functions or constants are related to mathematics. So that's why we call this math module. Okay. Again, all these are different examples. Uh, so like calling sine, cos, tan. Here a sine means inverse sine, that is pi by 2. The value will be sine inverse of 1 is 90 degree or pi by 2. So here the result is in radian. To convert to degrees, we use the function math dot degrees. So like that we can use the different functions, and these three are rounding functions. The ceil function means it is rounding up. Floor means it is rounding down. So here floor means 4.3 will go to 4. Even 4.9 also will go to 4 if it is floor. But if it is ceil, ceil means rounding up, floor means rounding down. So ceil means 4.3 will go to 5, but floor 4.3 will go to 4. And truncation means the decimal part is cut. All these values will become 4. Minus 4.2 will become minus 4. So ceil, floor and trunk are the three functions in math module 4, rounding operations. Okay.